February 14th, 1990 marked a momentous day when Voyager 1 captured our Earth as a tiny blue pixel from a staggering distance of 6 billion kilometers. Yet, just 34 minutes after this historical picture was snapped, Voyager 1's cameras were switched off forever, leaving the spacecraft blind to the cosmos. Fast forward to today, Voyager 1 holds the incredible title of being the most distant human-made object in space, journeying at an astonishing distance of 24 billion kilometers from its place of origin. Now, the burning question is, why were those cameras off for such a long time? And is there a chance they could ever be revived to capture the mysteries of the universe once more? Let's find out. Before we dive into the challenges and possibilities surrounding the Voyager 1 cameras, let's first take a closer look at what these cameras were like. So, Voyager was built back in 1970, and at that point, the best cameras NASA could manufacture were essentially early versions of television cameras. These cameras don't boast super high resolutions, they're limited to just 800 by 800 pixels. Nevertheless, they capture images in grayscale with 8-bit depth. One camera features a wide-angle lens, ideal for close-ups of planets, while the other, equipped with a narrow-angle lens, zooms in to capture finer planetary details and observes our solar system from a distance. However, before cosmic light reaches these cameras, it embarks on an intriguing journey. There's a filter wheel on board, housing violet, blue, green, and orange filters, eagerly awaiting the incoming light. Voyager takes multiple shots using each filter, permitting specific colors to pass through while others are filtered out. Thus, although the resulting images are monochromatic, they exhibit varying brightness levels, revealing the world through diverse color-sensitive lenses. Now, we know that Voyager's cameras aren't the best cameras we have. The question that arises is, hypothetically speaking, if we could turn these time worm cameras on, what are we going to see? Basically, Voyager 1 currently resides at the edge of interstellar space, positioning it as an ideal platform for studying the transition between our solar system and the vast expanse of the Milky Way. And this unique position offers the potential to capture valuable data about the interstellar medium, cosmic rays, and magnetic fields at the cosmic boundary. Moreover, if these cameras were reactivated, they could continue to photograph familiar star constellations, like the enduring Orion constellation. These images would remain virtually unchanged, despite Voyager 1's extraordinary journey, emphasizing the immense distances of interstellar space. From this distant vantage point, free from the interference of Earth's atmosphere and magnetic field, Voyager 1 might have the ability to detect and record data on cosmic phenomena, including supernovae, pulsars, and other enigmatic deep space objects, further enriching our understanding of the universe. Which is why scientists are to date willing to get any data they can from this age-old space probe. Now, let's talk about the incredible process of Voyager 1 that's behind the creation of those captivating images of the cosmos, a process that science has held faith in. When Voyager 1 took those captivating pictures and sent them to Earth, they weren't initially in full color. They needed a special process to become colorful and stunning. Now, let's explore the magic that happens inside the Vidicon tube. After cosmic light passes through the lens and filter wheel, it enters this incredible device. The first thing it meets is a transparent faceplate made of oxide. Right behind it is a special target plate. When light from distant worlds hits this target plate, something amazing happens. It releases tiny particles called electrons. The brighter the light in a particular spot, the more electrons are set free. These eager electrons then move toward the faceplate, leaving tiny gaps on the target plate, kind of like footprints in lunar dust. At the back of the tube, there's something called a cathode, and it shoots a bunch of electrons straight at the target plate. These electrons fill in those gaps, creating an electric current. This electric current contains the main image data, like a secret message from space, ready to be sent back to Earth. Now, Sending data from billions of kilometers away isn't easy. It's a bit like trying to send a postcard across the entire galaxy and hoping it arrives in one piece. Now that we know how Voyager's cameras turn light into signals, let's talk about what happens next. Each image taken by Voyager had about 5 million pieces of information, which may not sound like a lot today, but when your spaceship is billions of kilometers away, sending that data back to Earth is a big challenge. When Voyager 1 was a bit closer to Earth, its fastest data rate was around 115,000 pieces of information per second. Now, the question is how this immensely important data reaches the Earth intact. It would take 43 seconds to send a complete image back to Earth when Voyager 1 was a bit closer. However, today, the data rate has been reduced to a mere 160 bits per second. That means transmitting a single image would gobble up over 8 hours of precious time. And to add to the cosmic waiting game, Voyager 1 now resides an incredible 23 billion kilometers from Earth, meaning that signal would take a whopping 21 hours to reach us. But now, let's pay attention to the cosmic mystery. Why haven't Voyager's cameras been fired up in over 3 decades? To understand this cosmic mystery, let's rewind to Voyager 1's last picture-taking adventure. Remember that famous pale blue dot image? It was taken when Voyager 1 was about 6 billion kilometers away from Earth. At that point, our trusty spacecraft had gone so far that even our Earth looked like a tiny speck, just a speck of cosmic dust. What's fascinating is that Voyager 1 was on a unique journey. It was going to be the first spacecraft to leave our solar system and venture into interstellar space. To mark this historic cosmic departure, Voyager's team needed instruments that could detect interstellar plasma, a sign of leaving our solar system. But here's the cosmic twist. Voyager 1 was already 13 years old at this point, with many more years ahead before reaching interstellar space. To keep communicating with it when it reached that epic milestone, engineers had to do some cosmic magic to make it last. Like many space explorers, Voyager 1 uses something called an RTG, or radioisotope thermoelectric generator, for power. It uses heat from radioactive material to make electricity. Every year, this power source gets a bit weaker, losing about 4 watts. Today, Voyager 1 is running on just 57% of its original power, and its camera alone uses more than 40 watts of that power. So, to buy more time for Voyager, the team decided to save power. They also had to manage the spacecraft's memory, so they made a big decision. They removed the software that operated the camera. Amazingly, even the cameras themselves and the software on Earth that processed their cosmic photos have become part of cosmic history. Plus, the cameras and their heaters, exposed to the harsh space environment for decades, might not work like they used to. But let's indulge in a cosmic daydream. What if the cameras were still in perfect shape? What would they see? Some might think Voyager 1, so far from the sun, is floating in total darkness. But that's not quite the case. Even though it's 23 billion kilometers away, the sun's light still shines 16 times brighter than Earth's moonlight. The issue is that there's not much interesting stuff around Voyager to take pictures of. If it took a picture today, you'd mostly see a big empty space with a few tiny pixels representing the sun and some distant planets. For Voyager to capture something truly different, it would need to travel thousands of light years to see a noticeable change in the cosmic scenery. Do you think that the future of Voyager holds something incredible? Is it worth keeping an eye on it? Let us know in the comments. Make sure to interact with this video by liking and sharing. Make sure to subscribe to our channel and be the first to know about space. Till the next video, stay safe.